We want to breathe.
I want to breathe.
Eddie, you want to come upstairs with me?
No.
No. I don't want to miss out on the vets, Mom.
I'm not mom. He's followed me like I'm mom now. Holy crap.
And I'm back. Third time's a charm. Maybe I can break things this time.
You're welcome to break things. I don't care.
The other times it was Annie, so it wasn't me. All right. Hey, how's it going, DPI? Veronica Cure, Fox Cams, Wayne Johnson, etc. Looks like Nightbot is here as well. Good to see everybody this morning. It's morning Central Time in the U.S. We're about an hour away from Starliner making its much earlier than scheduled landing at White Sands Missile Range in New Mexico. One of the things that we can talk about there is why it's doing this, why it's landing early, why it never made it to the ISS, why certain things happened the way they did. One of the things that you may or may not have known about the initial trajectory of the Starliner is that when the Starliner launches aboard the Atlas V rocket, it does a shallower trajectory than the Soyuz or the Dragon capsule. And there's a couple of reasons for this. For one, it eases the G-forces on the astronauts. It's actually very similar to the flight path that the space shuttle used to use, in that the central main fuel tank, that great big orange balloon in between the two solid rocket boosters, this would basically empty as it lifted its way up to orbital altitude, but it never quite got to orbital altitude. And that allowed it, when it jettisoned the fuel tank always came back to Earth. It always burned up in the atmosphere. And then the space shuttle would use its orbital maneuvering system, its OMS engines, to raise itself the rest of the way up to orbital altitude. So why would you end up just short of orbital altitude with your main engines why wouldn't you just go all the way there? As I said to start with, because then when you jettison the rest of the stuff you're not taking to orbit with you, it always falls back to Earth, and you have less orbital debris to deal with. And the same is true with the Atlas. So when the second stage gets you most of the way, almost all the way up to the orbit that you want to be in, then the Centaur releases the capsule and itself goes back into the atmosphere and burns up. Again, this is lowering G-forces on the astronauts. One of the key things, though, is that aside from making it more comfortable, aside from making it cleaner for the orbital environment, is if something happens to go wrong on a crewed mission during the ascent, all you have to do is, I say all, like it's an easy thing, all you have to do is separate the capsule from the rest of the rocket and you're already on your way back. You don't have to do anything because you're not at orbital speed yet. You're not at orbital altitude. So the abort, it becomes easier to do because you're not committed to an orbital ascent yet. And this actually has borne exactly the intended result, in that when something went wrong with the Starliner and it couldn't make the ISS orbit, they were able to put it in another orbit that was stable and then bring it back to Earth fairly easily. So in that respect, this worked exactly as planned, just not the way we wanted. The sequence of events appears to have been that there was a timing error in the capsule. The capsule, basically, its timer was wrong. It's designed to pull what time it is, where it is, what part of the mission that it's in from the Atlas V rocket. And for whatever reason, according to one of Boeing's vice presidents who spoke on the issue earlier, they pulled the wrong number. And apparently it happened even before the launch happened. So they're going to have to go back and figure that out. But as with any major project like this, it wasn't just the one error, because the minute they separated from the Centaur and the upper stage maneuvering thrusters started going pretty much wild because it wasn't where it thought it was, and started actually one of the sets of maneuvering thrusters ran out of fuel. It was firing so much. At that point, ground controllers saw what was happening on their displays and attempted to send a command to tell it to, hey, stop doing that and do this instead. And that's when, as DPI is mentioning, what was with the communication issues with TDRSS? Every so often, you end up with communication gaps in the TDRS system. It's not supposed to be that way. There's supposed to be a couple more satellites in the constellation. There's supposed to be a couple more Earth terminals. But time and age and budgets have worked so that they do the best they can. If you watch ISS feeds of the video, you'll notice every so often it cuts out for 30 seconds to a minute to 2 minutes. This is what happens. You say it sounds like a planning issue. This would have involved plotting out all of the orbits of TDRS and all of the communication coverages. And the fact is, the glitch only needed to happen for a few seconds. And that kept them from getting the message to the capsule to get it back on an ISS-capable course. A few seconds later, however, they were able to put it in a different orbit as they got communications back. So you're not wrong, but it's like, I don't know what to compare that to. It's like planning whether to leave your house at one time or to leave 10 minutes later based on the traffic that you know is in your neighborhood. Will Starlink back up TDRSS? It possibly could, but that would be something that Musk would want to work out with NASA. I say Musk. Musk is technically not a part of SpaceX anymore. That's Gwynne Shotwell, who's the CEO. You're a mean one, Mr. Glitch. Oh yeah, that's been the case for a while.
Oh. Then why does he take all the credit?
Because he's the one that started the company, and everybody just remembers that.
Okay.
NASA administrator talked about a communication delay of up to 9 minutes. Yes, at the very worst possible orientation of all of the terminals, it could be up to 9 minutes. In this case, it wasn't. It was not that big, but still, it was big enough. So again, you're dealing with an imperfect system, and we've already had one glitch, and you'll remember DPI possibly from the same news conference that the same administrator said, if we'd have had astronauts on there, they could have manually done it, and that is also the truth. But we didn't want to put astronauts on this one to start with. This is a test flight. Let's see. So why don't wait in orbit? That would put the launch window 30 minutes ahead. You mean before they launch, DPI? I just want to make sure I'm clear on what you're asking. Once they're on the launch path, everything has to happen more or less right on schedule, or it doesn't happen. At least not the way that you want. And the thing that set off the cascade is the fact that the timing system in the capsule pulled the wrong number from the Atlas V rocket itself. The rocket itself, they think, worked absolutely perfectly. Is that IAINSE or?
Thank you, Lenise.
Okay, that's an L. Lenise or Lanes? Lanesy?
I don't know, but thank you. It was $100 tip.
Yeah, that's huge. Thank you very much.
You ready? You ready, Eddie? You get to do Eddie. He's got
Eddie?
it.
Where's Eddie? Where's Eddie? Yes, you floof. How are ya? It is an instantaneous launch, but due to shift in orbit a day. Yes, that's roughly correct. DPI. Perfect. Slobber, slobber,
All right.
slobber.
We're so close for the dogs to get their bones.
Almost there. That's at 3,000, right?
Yeah, I'm sure if we synced.
If we synced, if we
I'm not syncing bits. I'm not responsible for my math right now.
soinked,
Soinked. We soinked bits.
soinked.
But thank you.
Yeah, that's awesome.
I am ready to switch whenever you are.
Okay. It's getting almost to the time when I'm supposed to pop on here anyway for
Really?
this hour. If I'm taking this hour.
Do you want to take this hour?
This is the Starlink hour.
Is it the Starlink hour?
Yeah, it'll be at 5:45 when the stream goes live.
Does that mean
Hey, Mythtown.
Does that mean I'm done?
I don't know. I mean, you're not done, but you could be done with this for the moment if you wanted.
I mean,
maybe.
like done and go to sleep?
Yeah, probably not yet.
Okay. Done and laying down on the phone?
Maybe?
You drive a hard bargain. You sure you don't want to get up and stretch or anything?
I mean, I can do what we need to do. But I would prefer that somebody who's used to streaming does things like set up a YouTube video so other people can see it.
Oh, okay. All right, then I'm going to lay down for a little bit. Hi, Walker! Oh.
So yes, and to sum up what I was saying a minute ago, there were actually several by themselves little issues. Although the timing one is probably not a little issue. They really need to figure out why it pulled the wrong piece of data to figure out what time it was and what state in the mission it was supposed to be at. But beyond that, like I say, if astronauts are on board, they can manually override that. They have those controls. If it pulls the right data, then it doesn't have a problem to begin with. If TDRSS happens to be in the right place, or I say happens to, under normal circumstances, TDRSS is in the right place, and they just send the override command like they tried to do. And it works, and everything's fine. But since all of those little pieces were the way they were, what you ended up with is the ability for ground controllers to recover, to put it in a safe orbit, even if it's not an ISS-capable orbit, and to bring it back safely within 2 days of launch, which is similar to an abort mode that you would use even with a crewed astronaut, or a crewed capsule, sorry, and a capsule crewed with astronauts. Supply Dave with coffee and maple cookies, stat.
I mean, he's got maple cookies right next to him.
I think I don't mind if I do. But I'm only having one because the metformin will complain otherwise. It's fine. My blood sugar's under control. For a moment, anyway. Oh.
I was going to say they're tasty.
Don't I turn never to eat on stream? Exactly.
What?
I said, don't they say never to eat on stream?
Yeah, but everybody ends up breaking that.
Who is this kind man talking? He is a trooper. Thanks, Larry. I do only what I can, and sometimes not even that much. It's
I heard bits. Eddie heard bits.
Lanza gave us 260 bits.
Freaking awesome. You are amazing.
Thank you. And that is why we're here, is to raise bits and to help us keep doing this science. You can support us in other ways too. There's a Patreon link. You can go to Streamlabs and donate. Bits work perfectly.
We're just not going to math right now.
Yeah, we're just not going to math them out right now. And if you just don't have it, hey, that's my cookie. You can't have my cookie.
No, he heard the bit sound.
Oh, you're all right. I'll tell you what. Here we go. Mm-hmm. 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 Mm-hmm.
Here we go. Perfect. Hey, guess what?
Yes. Thank you, Keeper of Maps.
I win so hard.
It may, Larry. I've heard that. What it does for me is it actually, it and the Ozempic actually do this thing where I'll get hungry the way I normally get hungry, and then I'll walk into the kitchen and realize there's nothing here I really want to eat right now, and then I'm not hungry. And I can walk away and eat at a normal time, and I can eat normal amounts, and I don't feel like I'm starving myself. And I guess that's an unintended consequence, but it helps me stay on my diet. So, cool.
In the event that I am not around, all you need to do is make sure you click
Just click that button.
little arrow.
Okay, cool.
And then possibly play.
Right on, right on. About 40 minutes till the Starliner stream starts. And... That's a good cookie.
I know, right? Why do you think they're going to disappear? And why do you think there's so many?
This is... Oh, serious, dude. I just woke up. Who are you? I am...
No, really. Who are you?
Larry, this is Dave. This is our intro. Yeah, there we go. Thanks, DPI.
Who are you? Who is this? Where's Annie? Where's Pamela?
Annie's been on. She's done womanful work over the last few hours, trying to keep things going. Dr. Pamela's getting the last couple of hours of her beauty sleep before she gets back on. And we're going to be covering the Starlink landing. Hopefully that will go better than the launch did. And we're still running this stream. Still trying to keep things running for you in the new year. Not really anywhere near our goal, unfortunately. We some of you have donated, and that's amazing, and it's awesome, and we don't want you to feel pressured. We hate asking for this, but the reality is we have to, because otherwise this doesn't keep happening, really. DPI, what was wrong with the launch? The launch itself went okay. The rocket itself performed correctly. What happened was when the Starliner pulled its timing and mission status data from the rocket, it pulled the wrong information. And so it thought it was at a different time and space than it actually was. And apparently that happened even before... DPI, gee whiz. Oh, Lanza, thank you for resubbing. That's awesome. We've got 10 months. You've reached your 10-month birthday. That's awesome. Thank you. And one of the nice things about subbing on Twitch is that when we do have to run ads, you don't have to sit through them. So that's cool. If you don't have the money for a sub on Twitch, go over to our YouTube channel and sub over there. Once we get to a certain level, we can start pulling ad money from YouTube. And that's a bonus. That helps us out a lot. Let's see. Yep, there we go. Thank you, DPI. Any other questions about Starlink? The type of rocket that it was on? One of the interesting things I remember about it is that it used a dual engine upper stage. They call it a Centaur upper stage. That particular upper stage comes in two varieties. One has one engine and one has two engines. Obviously, two engines gives you twice as much thrust, roughly. Of course, you also have to carry more fuel and more plumbing, but the point is, but the Centaur dual engine upper stage had never been used on an Atlas V rocket before, at least before this Starlink launch. This was the first time an Atlas V had done that. Apparently, it worked perfectly. It's just the Starlink couldn't figure out where it was or when it was, which is inconvenient, to say the least. Let's see. Trying to remember if there was anything else interesting about this particular launch. The Centaur upper stage with the twin engines had flown on Titan rockets back in the day. In fact, I believe the Voyagers may have used the Centaur upper stage to help boost them out on their grand tour of the solar system. Don't quote me on that. By all means, check that out first. But that's what I'm remembering for some reason. Let's see. If you have any questions or any comments that you'd like to make in the chat, you can use the channel points to highlight them, or either use the purple star so I can see them easily. You may have noticed, some of you who either have just joined us or didn't hear from me before, I am wearing a monogrammed polo shirt. This is actually the company I work for. This is Intelsat. They're a satellite communications provider. They have several satellites in orbit, around 36 or so, something like that. They provide services on those satellites, various platforms, and service packages as well. And the reason that I'm mentioning that is because they have a program by which employees of the company can get paid for up to 8 hours every year for doing community service. And since I'm volunteering here for CosmoQuest, I brought it up to them and said, hey, this is what I'm doing. What do you think? And they thought it was worth paying me to be here. So I'm representing. I want to thank them for that. They gave us some plastic cups with lids and straws for giveaways. So I know some people are going to end up with those. Let's see. Rigel asks, what was the payload, if you know specifics, and will they have to rearrange the upcoming launch schedule to replace this payload? I think the main payload was that they had an AI robot. They call it Rosie. I remember that was the name. But that didn't really have any command or control authority, if I'm remembering correctly. I'm certain there was other cargo on there that was destined for the ISS. I just don't remember the specifics of what it was. I'd have to look it up. What would be necessary to have satellite around Neptune? Lots and lots of Delta V. As I've mentioned a couple of times, the solar system is super huge. It's way bigger than it often gets presented, because we don't like to think about nothing and how much nothing there is out there. Light, again, it takes about 8 minutes to get from the sun to the Earth, which as fast as light travels, that's kind of sobering. And Mars is half again as far as the Earth is from the Sun, and then Jupiter's more than twice as far from the Sun as Mars, and then Saturn's almost twice as far from the Sun as Jupiter, and then Uranus, and then Neptune. The only way the Voyagers were able to make the trips they were able to make was because of what they called the Grand Tour alignment of the late 70s and early 80s. The planets just happened to line up in a way that our launch vehicles were able to put those spacecraft on paths that let them use gravitational boosts from Jupiter and then from Saturn to get to the outer planets. And in fact, Voyager 1 could have gone to, I think it was Voyager 1, maybe it was Voyager 2. One of the two could have gone to Pluto back in the 80s, but we had recently made telescope observations of Saturn's moon Titan and found out that it had an atmosphere. It's the only moon we know of with an atmosphere, and that was more interesting. So they adjusted the trajectory ever so slightly so that the boosts put it in a position to fly by Titan, which then, of course, the gravity of Titan's not insignificant, and it adjusted that particular Voyager's course up and out of the solar system, and so it didn't get a chance to go by Pluto. It was like a slalom around planets and moons. Yeah, absolutely. Let's see. Is Intelsat one of the older ComSat comms? Yeah, it is, actually. I'm trying to remember which of the Olympics it was. If memory serves, it was the Mexico City Olympics back in like 1960 that were the first ones to get broadcast worldwide over satellite. And yeah, Intelsat was there. But yeah, in order to get to Neptune, just to finish that thought, you need a lot of thrust. The best way probably to get there, at least the most efficient way to get there, is probably an ion engine like they used for the Dawn mission. But that's going to take you a long time. So the question is, do you want to wait literally a generation from launch to orbital encounter? Or do you want to get there quickly the way we did with New Horizons and Pluto? New Horizons got there in, I think it was 12 years, 10 years. Thanks, Wayne. We've got it queued up already. And I think that's correct, Broken Symmetry. I think ESA did have money in the recent budget for a Neptune probe. But I think a lot of that is still R&D. I don't think there's anything... I don't think there's anything really solidified yet as far as that mission goes. Let's see. And Uranus really is in the same boat. Uranus, as somebody might say. They're both just so far away from the sun and not as big as Jupiter or Saturn either. So not only do you need more delta V to get out there, but you also need more delta V to bleed off that energy so that you can go into orbit around those planets. If you're trying to do something Cassini style. And all of that ends up taking away from payload in favor of fuel. Yeah, robot missions take years to set up. That is absolutely true. And so Cassini, that we'd mentioned before, Cassini was an amazing mission. They were able to stuff an awful lot of gear on that satellite. The people who set up the orbital mechanics for that mission, basically planning years in advance what they wanted to look at, how they wanted to get there, the types of maneuvers they were going to make, using different moons like Titan and Rhea for orbital assists, getting gravity boosts off of them so that they can change their orbit up and that kind of thing, maximize the fuel use. It's just amazing what they were able to do that with that. The math behind orbital mechanics is rough. There's a reason why we still use Isaac Newton's equations rather than Einstein's equations to do that, because the differences between the two are very small. Even when you're talking about orbital mechanics of a spacecraft around a large planet. And the differences are small enough that they're pretty quickly overwhelmed by stuff like aerobraking in an atmosphere, the solar wind, the influence of other planets, these kinds of things. So it's easier for the computers to crunch numbers when all you're doing is a little bit of calculus and not a whole heckin' lot of calculus. How much fuel would a mission save if it was launched from low Earth orbit rather than from the ground? If everything is coming up from the ground, which is how we would have to do it now and in the near future, then in one sense you don't save much of anything. You still have to get everything out of Earth's gravity well first, and then put everything together in orbit, and then maybe fuel it up, and then send it off. On the other hand, if we can get to the point where we can do things like mine the moon and use lunar resources and a lunar base to refine those materials, and then use manufacturing processes on the moon to make those things up. Even doing it on the moon, you're dealing with 80-something% less gravity than you are with Earth. And so your launch costs are a whole lot lower. And that's most of the cost of getting off of Earth in the first place. So if we can take that even a step further and start doing things in orbit or in microgravity out in space, if we can go to a Bennu or a Ryugu or a Hayabusa, and I think Hayabusa was actually the mission. It's Itokawa that's the asteroid. If we can recover those materials in situ and process them in orbit, in microgravity, in zero G, as it were, then all you have to do is fight against the sun, because obviously everything in the solar system that's stuck in the solar system is in solar orbit. So you're tied to the sun gravitationally, but not necessarily any of the other planets. And that does save you something there pretty significant. And it depends on where you're trying to go, how you're trying to get there, whether you're just doing flybys, whether you have multiple targets you want to do. But at the end of the day, yeah, if you can build the mission in low orbit or even in geostationary orbit or some form of orbit around Earth rather than launching it off the surface, that does save you quite a bit. Thank you for the gift sub, by the way, Scarlet Geek. That's amazing. Thank you for that. We really appreciate the support that we're getting on the stream here. It's awesome. Let's see. Where are we so far? Still about 20 minutes left on the stream. Nice. LHAT. I don't know what that is, Wayne Johnson. I'm sorry. HAL. There it is. I wondered if that's what you were trying to do. Yep, this is the CosmoQuest Hangout-a-thon. We're basically singing for next year's supper. So every bit of support that you can give us, we're really appreciative of. And the more support you give us, the less stress we have trying to make sure that things continue. And if we can get it to a certain point, then we can actually pay people what they're worth. That would be nice. Well, that's awesome, Scarlet Geek. Thanks very much. Close-up continuous footage of ice giant storm systems would get my vote. That's actually a good point, Broken Symmetry. The fastest atmospheric winds in the solar system are in order Neptune's in Neptune's storm systems and in Uranus's storm systems. Neptune storm systems can have winds clocking up over 2,200 kilometers per hour, which is stupid fast. And it's crazy because obviously something besides solar heating is driving those storms, because the atmospheric temperature is something like 70 Kelvin. That's not real warm. They think that has to do actually with chemistry that's happening in the atmosphere and combining with differential heating due to seasons. But for whatever reason, the situation in Neptune and Uranus's atmospheres is such that it drives super fast winds. Even just the regular jet streams are on the orders of hundreds of kilometers per hour. My fingers are not work very well today. It's okay, Wayne Johnson. At this point, our brains and our vocal cords aren't working real well either. Annie's or mine. I think it's kilometers per hour winds, Veronica Cure, but that's still like 1,300 miles an hour, and that's more than supersonic here on Earth. So it's crazy. Yeah. So they get everything out of Earth's gravity. That's the best guess. What percent of New Horizons mission fuel is used to get to low Earth orbit? Most of it, Rigel, honestly. The entire first stage, and I'm trying to, probably, and I'm guesstimating here, I don't really know, 75 to 85% of the upper stages fuel as well. It's just that last few percent that allows it to gain the extra speed necessary to get out and on its path. It then did flybys of Venus and Earth, and then Venus again before flying by Jupiter. It wasn't that close to Jupiter, but it still got a little bit of a boost from it. And when it launched, it was the fastest thing that we had sent up off the ground. It fairly quickly slowed down to below what some of the Voyagers are doing. But at the same time, it's, as far as a direct path out to Pluto, it probably couldn't have gone much faster. Oh, you're super welcome, Veronica Cure. Confession time. Geeking out over space science things in the middle of the night, early in the nerning, as it were. It's too late for night, but it's too early for morning. So we call it nerning. This is it's been a guilty pleasure of mine since I was a kid. I love this stuff. It's super fun. 2,200 kilometers per hour would mean that a fighter jet like the F-22 would hang in the air like a hummingbird. Assuming the turbulence didn't rip it to tiny metal shreds. Yes, DPI, that's about right. One of the things that I secretly dream about, won't be so secret in a second, is actually building a Cloud City style resort on the top of the clouds on Saturn. I mean, can you just imagine the sight of the rings overhead and the various moons going by and all that kind of thing? And of course, all you have to do is figure out how to float a Cloud City on hydrogen and helium gas, which is a challenge. And then even those winds are, if I'm remembering, 200 odd kilometers per hour. They're not slow. Ice diving in the rings, right? Secret revealed. Yeah. It's out there. I'm suitable for blackmail now. Atmospheric density of Saturn isn't all that great compared to the others. It's true. One of the nice things about such a resort, though, is that at the top of that atmosphere, your personal gravity, which we'll call 1 here on Earth, is only about 0.95 on Saturn. It's of course a lot bigger than Earth, but it's also a whole lot less dense. So at the top of the atmosphere, your apparent weight would be actually just a hair less than it is here on Earth. And Saturn's radiation is not as bad as Jupiter, but there is still a magnetic field. I am less clear on how intense that magnetic field is, broken symmetry. But it's definitely not Jupiter's. Jupiter's magnetic field is, and this always blows my mind, if you look up at Jupiter in our night sky and you see that bright white spot, now imagine the full moon glowing around that spot, centered on that spot. And that's about the size of Jupiter's magnetosphere as viewed from the Earth if we could see it from our eyes. And again, it's 5 times further from the sun than we are. If you could do that, why not Venus Cloud City? It would actually be easier, I think, on Venus, Veronica Cure, if I'm understanding things correctly. You can sell it as a new instant weight loss plan. Move to Saturn, lose 10% body weight instantly. No pills needed. It's true. It's absolutely true. Of course, you can do that here on Earth, too. If you're somebody who lives in one of the lower latitudes, say between 15 degrees north or south of the equator, and you move up to one of the poles, yeah, you'll lose 2 or 3% of your body weight. Niji Inverse just tipped us $25. That's awesome. Thank you so much. She said, except for the acid. Yeah, there's that thing about acid that loves to eat through metals and other materials. Yeah, Venus is a terrible place. There's just so much wrong with Venus. Wow. Yeah, it's, how do you start? People talk about, well, we could put a shade up and cool it off. And I'm like, that might help. What are you going to do with that atmosphere? Well, we could add some oxygen to it. Venus's atmosphere is big and dense enough that walking on the surface, assuming you could walk on the surface, would be like being a kilometer or 2 under Earth's oceans. That's the kind of pressure you're dealing with. Maybe this will help put that in perspective. Nitrogen is a trace gas on Venus. It's only about 4% of the atmosphere. Venus has 4 times as much nitrogen as the Earth does in its atmosphere. And it's 70% of our atmosphere. So, yeah, there's too much atmosphere on Venus. And it's the wrong kind. And magnetic fields and acid clouds, and it's just bad. It's a very long day, broken symmetry. That's true. They say bamboo will grow anywhere. I'd like to test that theory. Let's see. Is Betelgeuse still shining? Hey, Paranor, welcome. Hope you had a good sleep, my friend. Let me try, and I need to get back and see this question. I was about to say blah, blah, blah. And I'm sure I missed it. Okay, so Larry asked, is Betelgeuse still shining? As far as I know, it's still shining. It is measurably dimmer than it used to be. And as far as reasons why and what that means for tomorrow and the next day and the next day, who knows? If we knew, or if somebody makes a prediction and it comes true, then yeah, that'll be something special. Thanks for changing the title. Let me see. Yeah, we've still got about 13 minutes. So in about 10 minutes, I'm going to start trying to pull that over. And let's see, what other random solar system facts did I learn in the last week? Earth, you may know, has a Trojan asteroid. Oh yes, we are going to watch the Starliner thing. Hopefully we can do that on stream. And by the way, welcome and good morning, Astro YYZ. There's lots of rocks. There are lots of rocks. But the Trojan asteroid I'm speaking of is, and I forget its designation. It doesn't even have a name. It's just got one of those alphabet soup labels. It's morning. The Earth's Trojan asteroid is in the L4 Lagrange point. I'm sure I got that wrong. It's whichever one I was going to pick, it would be the wrong one. But for all that its orbit is a little bit chaotic, it's actually in heliocentric orbit. It's orbiting the sun, just Earth is tugging on it so that it doesn't get away. And apparently it's stable. We're going to have it for at least the next 10,000 years. So not technically a moon. So we really only have one moon. But we do have a Trojan asteroid, and it is tied to us, and it's going to be here for a while. So that's kind of cool. That sounds familiar, DPI. 2010 TK7. One of the cool things that didn't get a whole lot of press about the OSIRIS-REx mission is that on its way to Bennu, it did turn its cameras on the L4 point to try and look for other Trojan asteroids, and it did not find any. Thanks, Niji Inverse. Yeah, L4. Okay, cool. So that's some other science that OSIRIS-REx did. I'm sure I've mentioned this at some point to somebody. Good morning, Canada Kim. Thanks for being here. Speaking of Trojans, Jupiter has a whole bunch of them. Saturn has even more of them than Jupiter does. But what Saturn has that other planets don't have, as far as we've been able to discover so far, is that Saturn has Trojan moons. Let me explain what that means. For instance, the moon Titan, it's the biggest moon in the solar, not quite the biggest moon in the solar system. It's the only one with an atmosphere. Is big enough that it and Saturn have Trojan asteroids in Titan, Saturn, L4, and L5 points. And they do go around Saturn. So those are not just Trojans, they're Trojan moons. And Saturn actually has 4 of them. So that's pretty cool. Orbital mechanics around Saturn are ridiculous, which mad props to the Cassini team for the work that they did on that. Venus is a terrible place. We all knew that. Mercury is the only place in the solar system, as far as we know, where the sun rises twice every day and then sets twice every day, depending on where you are on the planet. Looked at from the outside, Mercury goes around the sun twice for every 3 planetary rotations. As such, with its fairly elliptical orbit, as it gets closer to the sun, the orbital motion of the planet outpaces its own rotation. So what you will see at certain points in the orbit is the sun start to come up over the horizon. It'll get up a certain ways, and then it'll stop. And then it will go back down below the horizon, and then it will stop. And then it will come back up and resume its normal trek across the sky. Bennu, slowly I rotate, boulder by boulder, rock by rock, pebble by pebble. Larry Weird's adapting poetry for us. It's totally appropriate. Ooh, now I want a waffle. That is 1,000 bits. That is ridiculous. Thank you so much, Astro YYZ. That is crazy. Thank you so much. And Eddie, who recognizes the sound. There you go, big boy. Nope. Kepler. Keeper. I know who you meant. I was thinking about Kepler a moment ago with Mercury's orbit. Let's see. About 7 minutes to the Starliner video. Yeah. That's pink fluffy unicorn dancing on rainbow spits. Kepler of maps. Nice. I think he'd appreciate that. All right. And if this setup was unfamiliar to Annie, it's totally foreign to me since I don't actually do these streams. So hopefully I can show this video successfully.
Well, I'm still in here, so.
Oh, I thought Annie is still awake. Crazy.
No, I'm not going to abandon you until you switch scenes.
Cool. Yep, Annie is here, Paranor. She's just in the other room having a not being vertical moment. Any other questions or comments from the chat? Just go ahead and use that purple star or either the channel points to highlight your text. Makes it a little easier for me to catch them. Yep, that's the one, DPI. Appreciate it. Apparently this is a pretty popular stream. I've already got, according to what YouTube's telling me here, I've got 3,840 people waiting. 4,063 people waiting. Yeah, there's some folks interested in this. So the orbit this time around will bring it over New Mexico from the southwest. So it will cross over a little bit of Mexico before it ends up over U.S. airspace. It'll deploy parachutes at the moral equivalent of about 10,000 meters. Astro, I was at, yeah, it was a series of unfortunate events, to coin a phrase. Yeah, that's pretty much it. The VP that was in charge of the project at Boeing came out and announced that there's a program on the Starliner that queries the Atlas V for what time is it and what stage of the mission is it. And it does that even before the rocket lights to get off the ground. And apparently it pulled the wrong parameters, which meant that the entire time it was in flight, it thought it was in a different place than it actually was. So that's something that they need to fix. And then, had there been astronauts on board, they could have manually overridden that and made the correction, and it would have been fine. Not saying we should put people on untested equipment, but had they been there, they could have done that. And then when they tried to send the commands to override it from the ground, there was a gap in coverage with the TDRSS satellite system, and that prevented them from getting to an ISS capable orbit. So, and yes, it absolutely would have been survivable. Apparently, the environmental parameters inside the capsule were great the entire time and are still great to this point. The solar panel and the power generation equipment is apparently working better than planned. Despite the overuse of the orbital maneuvering engines and the fact that they ran one set of them out of fuel, they can still transfer fuel to that system from other tanks. So there's a lot about this that actually went perfectly well. And because of the way the trajectory is designed, this basically amounts to a mid-launch abort test that worked absolutely perfectly. They got it into a safe orbit after the fact once connection was reestablished. And here it is 2 days later. They're bringing it back to Earth, hopefully safely. We'll see that in a few minutes. Yeah, no, Starliner did not go boom. For that, we are all thankful. Well, many of us, anyway. Got about a minute and 20 here.